Now, one of a river's main jobs in life is to find its way to base level. Base level is the lowest point to which the bed of a river can erode. So they're always trying to erode down to base level. Ultimate base level is going to be sea level. So that's kind of what all rivers are working towards. So rivers have two purposes in life. They want to reach base level and they want to keep moving. That means they can't have a gradient of 0. That means if they get the entire river to base level, they can't keep moving. So it's a hard job for them to meet both of these requirements. There are some local base levels, maybe a resistant bed. It could be another stream that it's trying to reach. It could be a lake that it's trying to reach. But like I said, ultimately, all the big rivers are trying to get down to base level. So if a river is far above base level, what does it need to do? It needs to erode down as quickly as possible. So in that case, the river is going to erode along its bed. It's going to erode the bottom. We call this down cutting. And it's going to erode down just as quickly as it can. What that does is it creates a river channel or a river valley that's very steep-sided. We call these V-shaped valleys because it looks like a really big V. These are mostly going to be in mountainous areas. You're going to tend to find them in higher elevations. On the other hand, if you have a river that's near base level, but it needs to keep moving, what does it do? Well, it wants to keep moving, but it doesn't want to erode down into the bed anymore because it's already near base level. So it's going to start eroding the banks. That ends up creating a meandering stream. So in this case, rather than just moving down, the river starts moving side to side. That meandering comes from the shape, right? It's a little meandering path that also comes partially from the fact that the river itself moves very quickly. So as it erodes along the banks, it's got a valley that's really wide with a well-developed floodplain. But it's this meandering stream that makes it very easy to recognize. So near base level, it erodes the banks and you have a wide, flat valley. Alright, so let's look at some definitions here. We're going to look at some features in a wide valley. Each curve on this is called a meander. So there's a meander, there's a meander, that's a meander, that's one, that's one. Alright, nice and easy. Now, you can see as you go around a curve, the outside and the inside look kind of different. And that's because partially where that thalweg is happening. Alright, so as your thalweg, you can see the maximum velocity. So here's the thalweg right here. As it goes around a corner, that thalweg is very close to the outer edge. The faster water goes, the more that the more sediment it can carry. So if it's not carrying enough sediment already, it'll start to erode. So this outside of the curve we call a cut bank, because essentially the river's cutting into the bank of the river. Alright, so let's look at an example. Here is a house. This is in January 1965. So you can see lots of erosion going on right here. It's probably a bad side already. You can see there's been quite a bit because this grass is actually overhanging, which means there was dirt under it when it was growing. Here's that same house in March. So less than 3 months later, that cut bank is expanded way out. It's also taken down these 4 trees. So you can see those trees had already fallen over. Probably a bad sign. And these trees right here, there they go. Alright, so rough place to live, right? So that's the danger of being on a cut bank. So if we're eroding on the outside, what's happening on the inside? The inside is where you get deposition, and in essence because the water slows as you go around the corner. So as it slows, you deposit. It deposits basically a sand and gravel bar. So this inside of the curve is known as a point bar. So point bar is where deposition is going to occur. If we look here, I believe this is the Snake River just below the Grand Tetons. You can see this is that nice wide valley. Even though part of it's steep, there's a pretty wide valley. That's a beautiful floodplain. And right here, you can see there is a point bar right around the corner. Now what that means though is as it's eroding along the cut bank and depositing on the point bar, your whole river system actually slowly migrating, right? I'm going to turn this on, and notice this cut bank and this cut bank keep getting closer and closer and closer. Oh, there they go. Now the water, it's going to take the shortest path it can, so it's just going to skip right over that. So notice it doesn't even go around that meander anymore. So this U-shaped lake right here that used to be a meander, but that's been cut off but remains filled, is called an oxbow lake. Eventually that oxbow lake is going to dry up, but you can still see evidence of it. We call that a meander scar, so you can still see where the meander was. Lots of oxbow lakes and lots of meander scars are really good indications that your river is really close to base level. For instance, here is the Mississippi River near Big Black River, Mississippi. So you can see here's the river as it is now. You can see lots of point bars, even though it doesn't meander a whole lot right here. There's a point bar, there's one, there's one, there's one. They're kind of going up alternating sides of the river. But if you look around, we can identify quite a few oxbow lakes. Here's an oxbow lake, there's one, here's one, here's one. Looks like this little one still has some water, that one still has some water. But if you look out here, that doesn't have water anymore, but it was obviously meander. Same thing for through here. So you can see how the Mississippi River right here has swept back and forth across this entire area. That means living anywhere within that valley along the floodplain is probably a dangerous area to be, because that river can move, and actually move fairly quickly. We'll look at some examples of that in class. So what this means is not only do we vary from the head of the stream and a steep valley all the way down to the mouth of the stream with a wide valley, but that stream that's up in the mountain is working on down cutting and eventually will open up into a wide valley. So you can also tell how long the stream has been eroded. So we had a big wide valley, and it's meandering more and more and more, and that valley is getting wider and wider and wider. You can also start to recognize cut banks and recognize point bars and cut off meanders even, and oxbow lakes. So this tells you sort of a very mature stream. Most of the time it's going to be close to the mouth, but the key is this is going to be close to base level because it doesn't need to erode down anymore. Now base level isn't always the same. For instance, a dam that's put on a river will actually create a reservoir behind it, and you get a new base level. So your river is going to change. In this case, what that river tends to do is deposit a whole bunch of sediment in that reservoir. And they have to dredge these quite a bit to fill them back up. But since the sea level is your ultimate base level, and sea level changes, that's going to change your base level as well. I'm going to show you an example. This is a feature called an incised meander. These are the goosenecks of the San Juan River up in Utah. It ends up draining into the Grand Canyon. It's a super famous site. Now, notice you've got big, beautiful meanders, which means it should be very close to base level, but you also have very steep-sided. This is the bottom of a big canyon. That canyon should be indicative of being very far from base level. So how do you have something that has both signs of being close and far from base level? Well, it's because the Colorado Plateau has been uplifted. If you backtrack 30 million years ago, this area is actually very low. Rivers actually flowed from Phoenix north towards the area that's now the Colorado Plateau. It's very low in elevation. A lot of the rivers there were very close to base level. You had these big, beautiful meanders. Look how close that was to cutting off this whole meander right there. But something changed tectonically, and the entire Colorado Plateau, the Four Corners region, was actually uplifted by about a mile. And now, those poor streams that were super close to base level are over 5,000 feet too high. So they're going to start down cutting as fast as they can, but they're not going to take the time to smooth out those meanders. So they just down cut through the meanders to create these incised meanders. That's canyon country up along the Colorado Plateau, but that's why we have such big, beautiful canyons, like in Canyonlands, like here along the Colorado River on the Goosenecks, or even in the Grand Canyon. It's because of that uplift. The uplift will make base level very far away. But increments of dropping base level, so if your sea level's changing over time, so if sea level just drops just a little bit, this could be because of maybe a cold climate phase, you get more glaciers or something. Alright, so here is a river happily moving through its floodplain. The base level drops a little bit, and the river's like, oh, gotta cut down in there. So it starts cutting down in. And what it does is it leaves this nice high flat part of that old floodplain behind. This is called a terrace. Now, let's say it drops again. There goes the river again. So now you have this beautiful wide active floodplain in the middle, but you've got two sets of terraces left behind. So this stair step features all along here is an indication that base level has dropped just a little bit. And these are super common around rivers. Here are stream terraces along, again, this is the Snake River at the foot of the Grand Tetons. You see these big, beautiful flat sections. If you've ever driven to California, so headed out on the 10 or the 8 across the Colorado River, or if you've even gone to, if you've gone up to Vegas, you would have crossed it too. Those are all great places to see evidence of stream terraces along the Colorado River.